So, welcome to today's Grasshopper workshop. My name's David Copete. I have a YouTube where I share exercises, techniques, and go over how to use Grasshopper. So, today we'll be going over, for those of you who are fairly new to Grasshopper, how to get started with exercises, techniques, and things like this. So, let me make sure that I have everything.
David, could you please unmute yourself?
Yep, got
Yeah.
it. So we're back. Okay, sorry about that. So first thing we need to do before we get started is set up our page so we have both Rhino and Grasshopper within one page. So what I do is I minimize Rhino and I put it here on the left-hand side. And then I will open Grasshopper here and then put it here on the right-hand side. The way we create a new file in Grasshopper, if you don't know, you go to File, New Document, and you'll see the things the same way that I have them here. So hopefully you guys are at this stage. And now we can get started with the tutorial. So first thing we'll be going over today is the mindset that we need to get into when starting with Grasshopper, because most of the things that we do within Grasshopper are going to be based off of knowledge that we have inside of Rhino. So what we need to do is understand how Rhino works carefully so we can transfer that knowledge into Grasshopper. So this is what we'll be going over today. First is the mindset that we need to get into when we start Grasshopper. So being careful and mindful as to how we model inside of Rhino. This way we can transfer all of that knowledge into Grasshopper. Then I'll be going over some exercises that can show you how you can model inside of Grasshopper. And therefore, we can then move into more trickier exercises that are more like real world exercises that we can do. And towards the end, we'll be answering questions and things like this. And if we have even more time, then I can show you some other tricks so you can see kind of how the workflows goes within Grasshopper. So with that being said, let's get started here. Like I said, most important thing is we need to have Rhino on the left-hand side and Grasshopper on the right-hand side. When we get started, now we go to a brand new file, like I showed you guys. Hopefully all of you guys are on the same page here. We'll go to New Document. And so when we start in Grasshopper, we can start modeling right away. We can, let's say, type in a circle and start like this to create a circle. But first, before jumping into Grasshopper, let's go back and understand how we model inside of Rhino, because since we've been using Rhino, depending on how much expertise you have within Rhino, you're going to be able to transfer that knowledge into Grasshopper. So let's start here inside of Rhino. I'll make this my main page. And I'll actually take this and delete it. Okay. So first thing we do is when we are inside of Rhino, let's say we want to create some geometry. Well, we have to be mindful as to the steps that we take to get started. So we're going to be creating a circle. That's going to be our first exercise. So what we'll do is be mindful of the steps that we take. We're going to first think of the geometry we want to create, which is going to be a circle. Then we go to the icon and we click on it. That's going to be the next step. So the clicking of the icon is similar to bringing in a component inside of Grasshopper. Then when we click on the circle, notice that we have more options. We have the location, the center of the circle, and we have different ways of creating circles. In the same way that when we click down here on the icon, we have circle from center, 2 points, 3 points, and all of these different ways. We'll be just going over creating a basic circle. So the first thing we do is click on the icon. Second thing is create the center of the circle. So we don't really think about this too much when we're working within Rhino, but when you create a circle, every time you click inside of this X, Y coordinate system, which is all this 3D modeling program is, it's just a coordinate system where you can produce your designs. Here in this coordinate system, we're going to pick the center of the circle. Now, when I click here, I picked a location. Now it's going to ask me for the radius. So that's the next step, which would become inside of Grasshopper, a component input. So the radius, we can pick it. We'll just go here to 25, and then I'll hit enter. Now that we have this circle created here, that is technically the output. So the steps that we took from the beginning were, first, what do I want to create, which is a circle. Then we find the icon, which is similar to in Grasshopper, a component. We click it. Then it's going to ask us here at the top, where is it going to be located? This is similar to the inputs you will see in your components. So the center of the circle, where is it going to be located? Well, I can click randomly, or I can type in 0, 0. And that's going to be the location of the circle. Now, the sides of the circle, we'll do 25. And so this is how we typically model within Rhino, which is straightforward. But what happens is the geometry, you can't really change it unless you scale it or unless you create a new one with a different size. So what I'll be doing here is showing you with this simple exercise for you, first of all, not to be intimidated with Grasshopper, because all it is an extension of Rhino. So if you know how to model in Rhino, you technically know how to model within Grasshopper. You just have to understand how to transfer your knowledge from one place to the other. So with that being said, we're going to be aware of the steps that we took here, and we want to do the same things parametrically. So all I'm going to do now is take these circles that I created, and hopefully you guys are seeing the same thing that I am. And I'll take this and move it. Now, the reason why I have this is it's called the gumball, right? And I use this one just to move it out of the way, because now we're going to be bringing back our Grasshopper page, putting it halfway on this side, halfway on this side. And now we can get started creating these circles parametrically. Here's the thing that I want to mention to everyone. You don't want to necessarily go too crazy with parametric designs at the beginning, because that will cause some confusion. You want to use short exercises that you can practice and you can know that you understand for sure. And from there, you can build upon your knowledge. So with that being said, we'll move these. Now we're going to be creating these circles again, but parametrically inside of Grasshopper. And you'll see it's the same thing. It's just different language, right? It's a different modeling language that has a lot of advantages. So to bring in a circle, in the same way that we click an icon here, inside of Grasshopper, we will double click. So the double click is the same thing as going to the command line and typing in a command. Or you can also go to your tabs in the same way that in Rhino, you can go to your tabs and look for how to create anything. Well, you can do the same thing here. We can go to the tabs, and we can see that under math, sets, vector, curves, which these are technically lines or curves inside of Rhino. If we go down here, we will see that under primitive, we have a circle. And we also have different ways of creating different geometry. So we'll start with the basic circle. Now, if we want to bring this in the other way, double click and bring in the circle. Now, in the same way that we can create circles from radius, 2 points, 3 points, tangent, fitting from points, we can do the same thing here. We can create circles in so many different ways, but this is going to be the one that we use for this example. When we bring in a component, the component is nothing more than an action that it will do. It's the same thing with the icons here, like I mentioned. The action is going to be a circle. Now, when we hover over it, it gives you more information about the circle. The circle is defined by blah, 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 this component. Now, other important thing that I definitely need to mention is if you do not see the component this way, it is because you don't have them displayed the same way that I do. When you go to display, at the top, you have draw icons, you have draw fancy wires, and you have draw full names. By default, if I'm not mistaken, they will be off, which gives you limited information. It still works. It's still fine. It's more of a personal preference, but I like to, for this workshop, let's go and turn all of these on. And the one thing that I do have additional is called sunglasses. It's a plugin, and that all that does is bring this tag above the component so you can see what I'm doing. And that will be useful for you to download also, but mostly for you to see what component I'm using. With this, now we have inputs and outputs for this action. The input is going to be a radius. Now, when I zoom in here and I select this, notice that there's already a circle being created here. And when I select it green, I can go in here and see that it turns green. So that is how you know that when you select something inside a Grasshopper, you're seeing it inside of the Rhino viewport, is when you select it, it turns green. There's already a circle here though. So why is that? Well, components sometimes by default will have already information set within it. So the radius, if you hover over the input, it'll say 1. And if we look at plane, it says world XY. So it's going to put it on the world XY coordinate system. And it's going to be a radius of 1. So it already has information. Now it's not located where we kind of have them here. How do we change the size? So to change the size, we're going to have to change the input, and the input could be set in different ways. Now, the typical way you see numbers brought in is a slider. So when I double click to bring in a component and I type in a number, let's say 25, and I hit enter, Grasshopper already knows that when you type in a number, you technically want a slider. And when you type in the number and hit enter, it will give you a number with a range. Now, the range of this one is going to be 0 to 100. And now we can plug that in and we see that it's at 25. We can go down to 0 or to 100, and we can create a range of values here to change it. Now, if this is one way of bringing in a number, the other way is you can bring in a panel. Or if you unplug this, the most basic way you can do it is to right click on the radius, set number, and change it here. But then you won't be able to change it with a slider. The next way is this way, where we can change the size. And lastly, this is more of a static way of doing it. If you bring in quotation marks, it's going to bring in a panel, which is nothing more than an empty text box. So here I'll go to 25, enter. And so this value I can use as the radius. And we can obviously change it in here by double clicking and changing it to whatever we want. So that's the way that we create numbers. There are many other ways of doing this. If we go to utilities or input, we have number slider, we have toggle. So when you create a slider or a range of numbers, you can also control it with a knob, with the digital scroller, and various ways that you see here. But for now, we'll go here to a slider, which is a typical way you'll see parametric designs. Now with this, we've picked the size, but we have not changed the location. So by default, it's going to set it here. Now, if we want to change the location, there are two ways that you can do this. One is fully parametric, which means that we would actually be creating the point here. The other way is actually going to Rhino and creating 2 points. So I'll go here to a point. Now I'll click somewhere here, and then I'll do that again, hit enter, and then click on another spot and create these 2 points. These 2 points is where I want the circles located. Now, other thing to note is when you're inside of Grasshopper and you're creating geometry like this that is not tied to Rhino, when you try to select this, you won't be able to select it no matter how hard. And you won't be able to move it either because it's within this Grasshopper interface, and you can't select any of this unless you right-click and bake, and then you'll be able to extract the information. The reason why that's the case is because technically the circle is never complete until you set a specific number and then bake it. So now, hopefully I'm not going too quick for you guys, but at this point, we want to take this circle, which is located here at the world XY, and we want to move it to those 2 points. So we will be going to a point component. And in here, I can set both of these. So set this one and this one. This empty point component will let me take this geometry from inside of Rhino into the Grasshopper workflow, because no matter what I do, I cannot set this circle on those points unless I tell Grasshopper where those points are. And so I'll select these two. We'll go to this empty point component, which is nothing more than a container for Rhino geometry. So we'll right click on this and go to set multiple points. So now that I've set those points, I know that they work because when I select it, it turns green in the same way that when I select this, it turns green. So what we do is the plane, the location of where the circle is going to be located will be at these points. And if I want them to be exactly where these circles are, well, I know I need to move this point to the center of this one. And I know I need to move this point to the center of this one. And notice that when I move the point, I didn't have to move the circle because the circles are referencing the points, which are the base geometry for the circle. So hopefully that kind of makes sense to you guys. Let's see. This is the next part. Now that we have points, right? So we've created points, we brought them in, we have these circles that we can change the size. Well, can we create a point parametrically? So these points we created inside of Rhino, which means we created it here and set them here so they could change the location of the circle. What I'll be doing now is creating a point parametrically. Now, at the top here, we can bring in empty geometry, like we brought in those points. But if we want to create a parametric point, we'll go to construct point, which gives you a point so you can plug in the location of it. So right now, if we hover over the input, it'll say 0, 0, 0. We want to change that location to somewhere in the X and Y. So let's bring in a slider. And this slider, I'm going to show you how to create a custom slider so you don't have to create a big range. We'll go here to 10.50.80. What it's going to do is set a slider that starts at 10. It sets it at 50 and the max is 80. So when you hit enter, you'll see that that's the case. 10, 80, and 50. So we'll plug this in the X. And notice that the point moves in the X direction. And now I can copy this down and plug it into the Y. So I can do Control-C, Control-V to copy a slider if you don't want to bring in a different one. And we can hold down Shift. Well, since it's only one input, you don't have to hold down Shift. But when you have more than one input, you hold down Shift. So with this, we see that we've moved that point. And since we moved this point can be the one that is where the circle is located. So you're saying that we don't necessarily need Rhino geometry. We can just create points within Grasshopper and move them around this way. Depending on how many inputs you have, you will also create more geometry. So right now it's only 1 point that this moves around. But if I wanted to create another point, well, we'll take this, I'll slide this down and tap Alt to create a copy. That's the quick way of doing that. And if we want to add another point, I'll hold down Shift and add it into the plane input. So now, well, they're overlapping because they're at the same location. Well, now we can change them. And now we have 2 circles created at that point. So we're seeing that geometry is usually tied to a location or to a point, and we can create it fully parametric, or we can tie it to geometry within Rhino. So go ahead and play with that a little bit. This next part, I'm going to show you how to create a parametric grid and use it in this same way. So let me unplug this and take this and just delete it for now. Any questions? Okay. So at this point, we have created a parametric circle. This circle is going to be located on points, but now we're going to create a parametric grid. So if you go here inside of Grasshopper into Vector, Grid, and you can pick any one of these, to be honest, whichever one you like best. I'm going to use hexagonal, right? So all this is it's going to create a hexagonal grid that is parametric. So let's take a look at the inputs, right? So when you have a grid like this, we're going to zoom in here and see that it's already been created. The size is going to be the size of the cell. The plane is where it's located. And the extents is how much in the X and Y. So let's change some of these values. We'll go to the size. We can do 5.5. And what this will do is give you decimal points. So when you do 5 and you add a decimal point, now you have a range of numbers with a decimal point. This makes it more subtle when you change the slider. So let's change the size of the slider here, and we're able to see how this changes. Now for the extents, you would never really use a decimal point because it's an amount of something. So let's go to 8 in the X. And then I'll slide this down, tap Alt. So as you can see, we've created it here. Now we can change it. We could change the location of where it is by taking one of these points. So maybe getting rid of this, and we'll build upon it. We have created this point, which is parametric. That can be the location of where it is. So we can move this around. And so now at this point, we've created this grid. Now notice that the grid output, you have cells and you have points. And when we created a circle, we input points. Now, the reason why it says plane is because when you plug it in, the point will be an XY plane unless you want it standing up. Now, I won't get into that right now, but the plane is going to be the points. So we can take any grid and set geometry to it. So now we're playing here with some geometry that we can use. So we can use this grid as nothing more than a way to organize this geometry, or you can also use it to create patterns and subdivisions, right? So this could be like columns, and then that could be the way that they're subdivided and then extruded up. So with this, you're able to see that not just with regular points, but with these points, you're able to create geometry like this. So hopefully you guys are able to follow along and see how this works. Okay. So what we've been doing is mostly using circles here. But in the same way that we can create circles, we can also create other geometries like rectangles. So let's go here to rectangle. And you're starting to see how scripts start building upon each other. We have inputs on the left-hand side, we have outputs on the right, and whatever is plugged in from the previous input is going to change the output on the right-hand side. Now, we don't necessarily have to preview geometry. This could just be how I want to organize my columns. So I can take this, right-click, disable preview, and now all we have here is nothing more than an array of circles that we can now, we're going to take these, turn them into surfaces. How? Well, when inside of Rhino, when we create a surface, it's going to be planar surface. Here inside of Grasshopper, it's going to be boundary surfaces. So I'll plug in that circle into the input. And what we've done is created a surface right on those circles. So I'll take, we don't necessarily have to preview this geometry. And now let's take this and we're going to extrude it. So in the same way inside of Rhino, if you want to give this some dimensionality, you have to extrude it. So we'll go to double click, extrude command. Now there are different extrusions. There's to point, linear, or along. So we'll go to extrude these surfaces. And notice that nothing happens, right? The reason why nothing happens is you'll know right away because the component is going to be orange and because when you hover, it says that there's a warning that it's not working. The reason is because when you extrude something in the same way that when you move something, you need to tell it in which direction. So the direction is going to be a vector. So we'll go here to unit Z. And this is the direction that we're going to extrude. Now it works, so it turned into kind of this whitish one. Also, when you hide it, it'll turn gray like this. So with this, now we have a direction, but the input, like I told you guys earlier, by default, there's going to be numbers already set into the components. So instead of 1, we'll change that to 12. So now we can change the size of the grid or the columns, the extent, and then here, the extent this way. So you're starting to see how you build upon geometry here on this side. So now that we've created this, I want to show you how to do that, but with a rectangle. Here's the thing. We'll get into that, but I think with the circle is going to be better. Let me show you what I mean. So we have these circles here. Well, let's say we want to create a footing below that. Well, we can use caissons, and the way to do that is we're going to offset this to the outside and then extrude it down as the foundation. So to do that, we can take the geometry that's already here, and we're going to offset it, offset curve. And notice that it's offsetting it by one amount, and it does it to all of them. This is one of the many benefits of parametric design, is that you're able to do things to a range of things, to a range of objects. Inside of Rhino, it's sometimes difficult to, let's say, offset everything at once. So with this, we'll create another boundary surface. Let's go here to boundary surface, which will create a surface inside of that offset. With this, we're now going to extrude it the same way that we did this here. Now, I can technically take this and copy it and plug it in. So this is sometimes the workflow that I use, but I'm trying to go slow and kind of be careful with this with you guys. So we're going to take this and we're going to extrude it. So we'll go to extrude component once again. We're going to extrude it down. So we know we need unit Z. And we want to bring it down by, let's say, 3. So when we have a surface and we want to extrude it, you need an extrude and a direction. So 3 in the Z direction. Notice that it actually overlaps it. The way to fix this is if the opposite direction will be negative. So unit Z, which is a vector, now it's a negative vector, and now it will be extruded down. The cool thing about this is we can keep changing the size, adding or removing, or this is actually the location of where it's going to be. The size can also change. And what happens is this becomes a parent object. What it means is that whatever is after it, so this circle has a radius of 2. And since this is offset, if I change this size of this circle, well, it changes the size of the offset. And this is actually what makes it difficult when you're not working inside a Grasshopper. Let's say in Rhino, you take a set of columns like this, you select them and you scale them down. When you scale them down, the dimension that you had originally is going to change. So with this, we don't have that issue because we have it tied parametrically like this. And we can always change the distance of the offset, of course, 2.50 or something. And then let's. Now, here's a bit of a technique. When you have geometry, let's say this circle, and you want them to be square footings, you can take that and do a box, or this other one also works, bounding box. In the same way that in Rhino, you can select an object, do a bounding box, and create a bounding box around it. We'll be creating a bounding box around those objects. So I'll disable the preview on the bottom part. And so now we're working with squares because it's the outer boundary of this. So this exercise should help you guys understand how to create arrays using grids, and also how to create basic geometries that you can offset and then have work like this. So this could be like an array of columns for a building. Okay, so we'll take this and middle click, disable preview. One thing I didn't mention is if you're working with a Mac or a PC, you will actually have different commands. So I'm not sure how the Mac one works with this one. When you middle click and disable the preview, you can disable the preview on everything that you have here. With Mac, I'm not really sure on that one. So right now, I want to see if you guys have any questions or anything, because I do want to share that file. I don't know if you have it shared, where we can subdivide the facade. Share that with you guys. So let me open that up. Someone has a question? Go ahead. I think someone has a question. So we just shared also the link for those of you who want to download the base model for the next exercise. So go ahead and download that. So if you want to set the distances of the grid, this is what you would do. You'd go here at the top. We're going to go to vector. Depending on what kind of grid you want to create, there's rectangular and then square. So if you want to be specific, you can pick the size of X. So we look at the inputs here, size of X. By default, it's going to work. So size of X by default, it says 1 and 1. We can change that to 15 and 15. Or if you want them to be different, 15 and 20. The thing is here, now you can use the points to lay out any geometry. So if we took those points, sometimes they won't be visible within the component when you select it. So you do, in some cases, have to bring in an empty point component. This way, you can get the points of the corners. Now, you also have cells, which will be these, and you can use those cells by offsetting them. So when you offset them, they offset to the outside. So this is where we would actually also bring in a negative component, and then say, when I offset, I sometimes bring in some decimal points, so it's a little bit more subtle. And so this is the way that you can use the cells on the inside, right? So you can offset them. This could be like a windows or whatever. You can also use the center of those cells. So if you don't want the corner points, you want the center points, well, there is a component called the area component, which brings you the centroid. So if you plug those cells into the geometry, you can actually create geometry on the inside of those cells. So within a component, you can use it in various ways, in whatever way benefits your design. And that's one of the things that is kind of tricky, but it's also an advantage, is that there are different ways of creating same geometry. And it really does come down to what you're trying to do at the end of your design. So hopefully that clarified a little bit of how you can use different types of grids. And then in here, we can, let's say, create circles on these centroids and then give it a value. So 2.5. Right? And then on these, you could say, I want them to be polygons. So from the center point, use these as the location of the polygon. How many segments? So a polygon, you can pick how many segments. So if we said 4, it's going to be a square or a diamond. And now the size, we can change that too, right? So we'll take this, slide it, copy it, and plug in the radius. So we can now change this. So you can create patterns using this grid, and we don't even have to show the grid. And you can, instead of circles, use, whatever other shape. Now, the cool thing about this grasshopper is, let's say you have this and these overlapping. Well, there's something called, let's go here, called region intersection. If with this one, which will be where these two intersect. So I'm just showing you some cool things here. Where these two intersect. Let's see if I'm flattening this so it brings in the information organized. Let's see. Oh, give me 1 second here. Let's see if we can change the size. What I was trying to do here is you can take geometry like this where they overlap. Let's see if region union. So we'll take this and this, and where they overlap, that is what can be extracted. So let me show you here. So we can take the difference, or them being joined together, kind of like this, two different, and create custom patterns and stuff like that by just overlapping geometry. Now, this is getting a little bit outside of what we were doing, but it's great. I'm really happy that I was able to clarify that with you guys. Any other questions or anything like that? I'm keeping an eye out on the chat here too. So now we'll take this middle click, disable preview. And now let's go to the model that we want to create here. Okay. So hopefully you guys have this base model. Let's see if this will work. Okay. So I'm setting it up here with a new Grasshopper file. And I'm showing you more of a real world case scenario, right? You can create geometries inside of Grasshopper fully parametric without needing to use any models. But the reality of the situation is, let's say you're going to have either a project or an assignment or something that you have been given and you want to use Grasshopper with it. So what I would say is, once you have your base model, this is going to be the base model. All we'll be using is this surface. So when we have a surface or something like this, we're going to first go to Grasshopper, double click, and bring in a surface empty component. Now you're starting to notice that these that have the black background are empty components that you can bring Rhino geometry into Grasshopper. So we'll go here, set one surface. Now we'll take this and hide it. So we know that now that it's been selected, it turns green. So we know that we can work with it. Hopefully you guys are at this stage and we're able to download the file. Now we're going to take this and be subdividing it using random points. Now here's the catch. If you've ever thought about this, creating random points is really difficult. It's actually one of the trickiest things because you have to make the decision, right? Now, Grasshopper on its own has a component that helps with that. We'll go here to vector, grid, and populate geometry. You can also do populate 3D or populate 2D. When you do populate geometry, it will create random points on this surface. So we'll take the surface, plug it into the geometry, populate geometry, is just going to be random points. Now, when you plug in the surface, now it knows where to place them, and it's going to have some default numbers in here. The count is going to be how many points, The seed is going to be more random options. Okay, so count, let's change that to 50. You see that we can change how many points we have. Seed is going to be also important because sometimes the random points that you get is not what you want. So we'll go to 71 and then seed. We can just go to, let's say 4. It'll create, every time you change this slider, it creates a new set of 71 points randomly arrayed on this surface. With this, now we can do the Voronoi subdivision. Now here's what I want to say about Voronoi is Voronoi is nothing more than a process of subdividing cells efficiently. People sometimes think that Voronoi looks like cells because that's what Voronoi is, but technically a hexagonal pattern is also Voronoi because it has all of its subdivisions perfectly subdivided. And so don't think of Voronoi so much as a specific pattern, but a process of subdividing points and information evenly. So what do I mean by this? Now we'll take these points that are randomly set on the surface. We're going to go to a Voronoi, and we're going to use this one. Now there are other Voronoi components that are useful in other cases. We'll be using this one. Now the points, well, when we see this component, it doesn't work because it needs some inputs. It needs some points, which will be this, a radius that can change the pattern, but the most important thing is going to be the points. Now, this is what people think of Voronoi, of the Voronoi pattern, but it's nothing more than random points, and this is calculated, the midpoint between those two, the midpoint between these two, the midpoint between these two, and that is how this is created with a random set of points. Now you're going to see that it goes all the way out to here because it does need a boundary. Technically, these could go out further, but we need a boundary, which will be our base surface. Our base surface has outer lines, and it's a planar surface, so we can use that as our boundary. I think I'm moving this around too much. I'll be more subtle. Okay, plane input is going to be also where it's located. Now it doesn't need it for this one. And now that we have the pattern, we don't necessarily have to preview the points. So with this, we can change the amount of subdivisions if we want them to be just minimal like this, or you can make them kind of crazy like this. I'm going to minimize it so we don't get stuck in the middle here. And that's the other thing is you don't want to add too many points to then do some actions later on. I would rather you simplify your geometry and then work forward that way, knowing that maybe later you can increase it and not crash your computer, because this calculates multiple actions at once, and you probably had those issues before. So with this, now let's make this structural or something that we can use here. With this version of Grasshopper, we do have multi-pipe, which is very useful and it looks really clean. But the typical way you can also do this is bring in just a line or a pipe, which you can use with these curves. Now, I'll be using the multi-pipe today, and it looks really intimidating because it has a lot of inputs, but there are only a few that we'll use. So to start, the cells are going to be the input. And automatically, you don't necessarily have to do much because it looks like it kind of works. But the other inputs here are going to determine attributes of this subdivision. This subdivision can have the strut size, so that's one of them. And I will change that by creating a slider of 1.5000 into the strut size. But notice that when you increase that, kind of these connection parts don't work. So this is where I decrease this, and I'll slide up, tap Alt to create a copy, and do that twice. Because we're going to input this into the, let's see, node size. This will help kind of that connection and even turn it into something like this, which is a little bit extreme. And then this one as the end offset, if you see that nothing else is working, you see here. So this takes care of these two, take care of the connection here. And then this one takes care of the strut size. And it's not as accurate as using a regular pipe because this is going to vary. The size is going to vary throughout. And at this point, we can now increase the subdivisions and see if that's kind of the design we're trying to go for. Hopefully you guys kind of see how that works. And so we'll take this, slide it down. I'll tap Alt and disable the preview on this. So now we'll be doing a, not necessarily a Voronoi subdivision, but a regular rectangular subdivision. Oh, someone had an issue with not being able to open the file because if it was not a regular or not a newer version. That's fine. If you don't have the newer version, then just create a rectangle and then bring it into the Rhino geometry the same way that I did. And if you can't use multi-pipe, you can probably just use regular pipe. There are some issues with this one that would need to be fixed, and it's due to the size and some of these things, but the best one, it is going to be the multi-pipe. So just saw that question here pop up. Okay. So now that we have this down here, this part, you won't have any issues if you have an older version. We'll be using a regular subdivision, a rectangular subdivision using isotrim. So with that, this next one is using the same surface. So I'm taking that surface, selecting it, set one surface. With this, now we're going to subdivide it using isotrim. Now, isotrim is the most common way that I subdivide surfaces. And with isotrim, you actually have other ways of taking that pattern and making other custom patterns. So when we have a surface, we're going to bring isotrim. Now, isotrim is what subdivides the surface, but you have to bring in two components. Number one, isotrim. Number two, divide domain squared. Now with these two, all we do is we take the surface, plug it into the domain, this surface output into the surface input, and this plugs into the domain. Now what it is Isotrim divides it, and this sets the U and V count, which is how we look at surfaces in U and V rather than X and Y. So for the U, we can change that to 15. And the V, we can change that to something like 8. And 5. That looks good. Okay. Once we have it subdivided, we don't need to preview the existing geometry. And that's the reason why you see it kind of funky there, because it's overlapping. So what I'll do is I'll take this, disable preview. And now we'll be taking this and turning it into a wireframe in the same way that we did for the Voronoi, but we'll be doing it for this one. Now, isotrim, all it is surfaces that are output here. Now, if I take this, middle click, and bake, all we did was subdivide that surface into these panels. Now, these are individual panels, which means that this has a line segment, this has a line segment. So it technically has overlapping geometry, and that is not ideal. Let's see here. Okay. That's not ideal, because then if I were to turn this into a wireframe, then we have two pipes on top. And that's actually the issue that we had with the Voronoi one, is that we have also overlapping geometry. And with this, we then need to join it. So I'll do the brep join, flatten the input, which means that they come in organized in one long list. Now I'll disable the preview here. Now, if I take this and I bake it, this is actually one joined surface, like it says here, brep join, and it only has one line segment. So this means that now, if I were to extract just the lines, I'll go here to brep edges, and with this, I'm able to extract the interior lines and the top lines. So why is that useful? Because you can extract the naked curves, which are the ones on the outside, and the interior curves, which are on the inside. And those could be different size. So go to pipe, plug in the interior curves into the input. The caps, we can change either to flat, round, and we can change the radius here. So I'll go to 0.7500. And we can do the same thing to the outside. So we'll take this, tap Alt to make a copy down here. And now, instead of the interior, we'll do the exterior. And this could be a different size. So the cool thing about this is we can also go in here, let's say inside of Rhino, and create an interpolated curve. Extrude it. And this be what it's set to. And we can rotate this around too. So we can have more subdivisions on the inside. And we extracted the naked curves, which go to this one, which can increase, or these interior curves. And it can be, let's see here, if we do cage edit and bounding box, you don't necessarily have to do this. I just want to show you that no matter what we do to this surface, let's see here. We can set it back to this one. Set one surface. And so that's how we extract a wireframe from a surface. So let's change this back to something smaller. Okay. So now let's say you don't want to do a wireframe. So we'll take this disable preview. Well, you can create options within your script. You can say, okay, I don't necessarily like the way that that wireframe was created, but I do want to still use this and offset them to the inside. So I'll go here to, first I need to, these are surfaces. So I need to extract the lines. So I'll go to a curve component. We can also extract it this way. If we plug in that surface into an empty curve component, it will actually take those curves and put them in here. Now we can offset curve. When we plug that in, by default is going to offset to the outside. So we know that if it's offsetting in an opposite direction, we bring in a negative, and the distance doesn't need a vector or anything. We'll use a value of 0.500. Now let's take this and this offset, let's loft it. What happens is the information is not organized correctly. So the way to do this is using graph tree. Now, if you're a beginner, this may not make too much sense. And all it is the way that the information is organized. Let's see here. This should, okay. So at this instant, that's not necessarily working. So this is the trick on that one. We're going to offset it by 0. You'll see this will work sometimes. It's the way that the information is organized. So we'll do this. When you offset it by 0, it keeps it in the same location, but it organizes the information the same way that this offset is. And so now we're able to change the size of that offset and loft it together to create those panels. Now at this point, we can also take the inside panel. So it's going to be this one. And we'll create a surface right on it. So we'll go to boundary surfaces. So now we have the frame and the inside portion. Now to give it some dimensionality, we'll take this and extrude it out. So we'll take this we'll go to extrude. And when we look at which direction we want to extrude, I look at this widget down here. There's the X, Y, and Z. We're going to be extruding it in Y, but negative. So I'll go here to unit Y, bring in a negative component. Now we'll give it a value of, say, 1.5. A little bit too much. And doing the same thing to the glass. But rather than extruding it all of that, it'll be less. So this, and we can disable the preview on everything else. And so at this point, we can change subdivisions, we can change the frame size, and lastly, what makes Grasshopper such a powerful tool is being able to do things like curve attractors, where all of the offsets of this frame would vary. And so you can actually have them be larger at the top, larger in the middle, and create dynamic patterns that way. The part that I was going to get into now is using colors. Okay. So now you have this and this. We're going to take the panels on the inside and bring something in called a custom preview and a color swatch. So when we plug this into the custom preview and the color swatch into it, now we can change the display color. And same thing with this one. So that's these here and these here. So does anyone have any questions? How are we doing with everything? There's probably one last thing that I could show with this. But I first want to make sure that everyone is kind of good. If you guys want to pause for questions or anything, make sure to let me know, because this last part take a little bit. Okay, so if I don't see any questions here, we're probably good. And so now let's take, you know what, I'm going to copy this down here. And disable the preview on all of this. This way I can go back here. Okay, all I've done is I've gone back to the place where we subdivided with isotrim. We have offset it to create the frame. And so now I want to show how to take something like this. So I'll go here inside of Rhino and do duplicate edge. I'll select, see here, because I think my layers, give me 1 second. I'm trying to fix my layers here. Actually, this is what I'll have to do. I'll create a line segment from the beginning to the end of that surface. This is going to be the curve attractor. So I'm going to show you here how a curve attractor works on a pattern like this. So you can use Rhino geometry or you can use Grasshopper geometry. I'll just be using this curve. So what I'll do is bring in an empty curve component, go to set one curve, And now notice that when I move it and I select it, it turns green. So we know that it's working. Now this curve is going to be plugged into curve closest point. Now this curve is plugged into the input. It still doesn't work because it has orange, and we need to have points that it reacts to. So what points within this grid could it react to? Well, the midpoint of each and one of these cells. So I'll go to an area component, plug in these rectangles into the area component, which gives me the center point. Now those centroids will go into the point, and I'll flatten the input so it comes in organized correctly. Now notice that all this component does, is it calculates how far this line that I created is to the grid. And it will create a varying sizes that we can use to offset this. Now, I'm actually noticing that this needs to go all the way back here because we can't have the outputs work. You can't have the output of this one then plug into the input. It causes issues. So this curve calculated to where this line, these points are, gives us different distances. Why do we need different distances? Because by default, we only have one value for the frames, and we can change. We know we have 50 frames, but we can have 50 different values for each frame and then have them vary. So here we have distances. We have different 50 values, and they vary depending on how close they are to that curve. So at this point, what we need to do is take these numbers, because they are too big, and you'll see here, they are too big. So what we need to do is make them smaller. How do we make them smaller? Well, they need to be at least 0.378 so they work correctly. So what we'll do is we'll take this distance, and we need to remap the numbers into smaller numbers. This is a little bit advanced, but I want to show you how this works. It's an important thing to note. So what are these values? Well, first, we're going to bring in 3 different components, and you always bring these in when you remap numbers to other numbers. First is going to be construct domain. So the first one would be remap numbers, then construct domain, then bounds. And if you're new, this is probably like, oh man, all this stuff. But what happens is you do this every time you remap numbers. So it seems like, oh man, like how does he know this stuff? It's because I do it over and over again. So these 3, remap numbers, bounds, and construct domain, we'll be using the distances that we want to change, use those as the input of the values. So we tell remap numbers, these are the numbers that were there originally. Then we plug this into bounds, which gives us the biggest and smallest number. So the smallest number is 0.5, the biggest number is 11. And we know that because we see the numbers here are really big. Now we plug the domain into the source. And so now what's important is the target, because this takes existing numbers, spits out new numbers that are small. So what's going to be the target? Well, they have to be at least around here. So I copied that slider here, and I'm copying the slider once again to create 2 different sizes. Now, the important thing to note here, the first distances were 50 and they were large, starting at 4. Now the remap numbers are 50 and they start at 0.2. So now we could take this, plug that into the -1, because we know we have to offset to the inside. And so now, rather than it being one value that changes all of the frames, well, it is how close they are to that frame. So let's not go to 0 necessarily here, but here we can see that and you could do the opposite. So now what we have done is if I disable the preview on everything here, including all of our geometry except for the outputs, let's see here. I'll disable the preview on the inside portion. Actually, I need to show once again because we have a line segment here that is what it reacts to. So we're able to create gradients. Now we could have done this with the Voronoi one, but you could do this with any pattern as long as you have the grid points and then a curve that matches to it. We can also see how this can work, right? If you rotate this around, or even if you scale it down to a small line segment, it becomes a point attractor. Same thing. So hopefully with those, you saw from the beginning, like how to get started all the way out to kind of crazy remapping numbers, which is not crazy. It's nothing more than having different values for each frame to offset. And with that, I think that will be the conclusion of today's workshop. Hopefully that made sense to you guys and I didn't lose you guys anywhere. To me, honestly, Grasshopper is super exciting. It's super intimidating, but it has so many benefits. And in my opinion, it makes you a better designer, hands down. Understanding how things come together, how you can use the data, and basically understanding how to model in a more rudimentary way, because technically when you go to parametric design, you're actually stepping back a little bit and you're going back to the basics, if it makes sense, where you're able to show all of your steps laid out here. And so if you send this to someone, they'll know exactly how you made it. But when, let's say you receive a 3D model from a client or another person, you don't know how they made it. You don't know how they got to that final result. So this is a cool way for you guys to see it. Oh, I'm seeing some questions here. Do I tutor individually? Yes, I do private tutoring. And I also have a YouTube where I have tutorials, exercises, and techniques. So yeah, this is, hopefully you guys enjoyed this workshop. Last thing I want to say, okay? You want to pick an exercise or tutorial or something that you're excited about, and you can kind of go slow, go really, really, really slow, understand how it all comes together, maybe have a script by your side so you can see how it works, but then your ultimate goal is to be able to create a script on your own without seeing anyone else's, and just do one exercise over and over and over again, and then it'll click at a specific point because it's a different way of modeling. So hopefully that helps you guys a lot too. And if anyone else wants to jump in and ask any questions or anything else, yeah, make sure to let me know. I'll save this file and share it with the admins. And so you guys can also have a copy of all of this stuff. And yeah, so I'll be closing down my camera. Thank you guys for joining. It's exciting time to learn parametric design. I'm honestly, like, for me, I think that parametric design can make everyone a better designer. So that is why I do this. And it's also a lot of fun. So thank you guys for being here, and I'll see you guys on the next one.